Welcome everybody to this webinar on domain-driven design and data mesh. I'm here today joined by Peter and Kenny. And Peter, could you give a short introduction of yourself?
Yeah, sure. Thanks, Niels. So my name is Peter Kromhout. I'm a data architect and consultant here at Xebia. I've been working in IT for about a decade now, and about half of the time in the data space. So I've seen the transition from a central data warehouse to a central data lake, and now to this decentralized data mesh concept, which is very interesting, and I'd like to talk a bit more about that with you guys today.
Yeah, great. And Kenny, short intro?
Yeah, I'm a software architect and domain-driven design expert at Xebia as well. And I have a background in software development, worked in a lot of asset management companies where I've worked on microservices, worked on the architecture of microservices and event-driven systems. So,
yeah, thanks. And my name is Niels. I'm the CTO of GoDataDriven. Been working in the data space for over 10 years on a lot of different data platforms, data lakes, etc. Before we dive in, this is the second, let's say, webinar on data mesh. Previous one was more general. It's proudly hosted by Xebia. And actually the reason why we're here today is because you approached me, Kenny, right? You wanted to talk about this combination of domain-driven design and data mesh. So why is that? Why
yeah, so working in a space for some while now as an architect, I've seen the whole decentralization from a microservices perspective, and I see the same happening here. But before we dive in, I was thinking about how can I explain this, and I always like to tell stories from my childhood or background. So how can I explain the problem, what's happening here with the decentralized to centralization? And it has everything to do with ownership, a thing that is a big concept in domain-driven design. More on that later. But when I was young, I made a lot of mess in my room, as you can see here, right? So my mom got annoyed. Why is it such a mess with all this information here? So what she did was actually try to clean that mess, but then I couldn't reach my things anymore. I didn't know where it was, right? So I got annoyed by it. And then she got annoyed because she's like, yeah, I need to clean this thing up for you. And that's the same, I think, a bit with the data mesh. She solved it by just getting one basket, put everything in and moved it outside my room. So have fun moving it back now in the correct place. And that's how she solved it. But that's why we're here, because I think the same is happening now with the data mesh and the data architecture, right?
Yeah. So looking at organizations, I think a lot of organizations nowadays, they don't have their data management in order. So instead of getting to this data mesh concept that they strive for, they get into a data mess, nicely visualized here also as a kind of a messy room, right? And it's important for organizations to have this in order, right? To know where's the data coming from, what's happening with the data, when it's being consumed and used and shared with others, and how do you use it in the end to get value out of it. But a lot of organizations don't have this in order. So there are some consequences. Thanks for that one. Yeah. So organizations suffer the consequences, and we have a couple here depicted. So first of all, businesses miss out on opportunities. This nice little graph clearly shows what happens in practice, right? So management wants to make decisions based on data, but they cannot trust the data that's happening. How often have you been in a meeting that some nice KPIs and reports are shared, and the first response is not, how can I use this to improve my business or get more value out of it, but I don't trust the data, it's not correct, right? So that happens all the time. So you miss out on opportunities. A second one is that it is a waste of resources. This is a report from the Kaggle survey from a few years back, and you see that about 40% of the time spent by data professionals, engineers, data scientists, etc., is being spent on finding the data, getting to the right source, getting the data in their hands, and then interpreting the data, understanding what it means, and then cleansing it. So that's a lot of time. 40% roughly of your engineering time is spent on that. And I'm not saying it can be brought back to zero, but if you can get 20-25% return on this, that's already a lot of effort and resources you can spend on getting value out of the data. Oh. So it's a waste of resources. And last, but definitely not least, you break the law. well, everybody knows GDPR, but there are some other regulations around the world that have to do with data. And from GDPR, it says, for example, if you use privacy data, if you use personal identifiable information in your data processing, you must be able to show what you do with that data. So what the flow of data is through your organization. And if you don't have your data management in order, you cannot show that, right?
Yeah.
So you break the law. And you see that, well, on the picture here, you see the top 20 biggest fines. It's growing every year, the number of fines being given because of GDPR. And it's not only the big tech companies, you see them in the top, but it's also smaller companies such as, well, H&M, British Airways, the Marriott hotels. So also a lot of smaller organizations have to deal with this. So it's really important to get your data management in order.
Yeah, makes sense.
So
yeah, this is what we're going to talk about today, right? How do we do, or why do we do what we do? Talking about that from centralization to, well, we've been here before, as I mentioned. What do the data mesh principles have to do with the data management, and how do we get that data ownership, right? Last time we talked a lot about the technology, about data mesh, and now we're going to see, okay, how do we actually do that, and what's the engineering way of solving this problem, and actually why is it a sociotechnical approach, right?
Yeah, and maybe before we actually dive into the content, right, it would be great if we could make it an interactive session. So if there's any questions from the people watching this video stream, but also present in the room, just feel free to use the chat or raise your hand, and then we'll go into trying to answer all those questions.
Yeah, we love a bit of interaction, and I can imagine that a lot of questions will pop up during this workshop. So,
great. Yeah.
Shall we kick it off?
Yeah.
Go ahead. So why do we do what we do?
And what do we mean with we? When we talk about we in this context, it's the data professionals in this space. So it's data engineers, data scientists, but also the architects, the data leaders, the audience that we have today. Oh. And the question is, why do we do what we do? For me, the answer is we are trying to help our organizations use data to make better decisions, right? Informed decisions. That is why we do what we do every day. I hope you feel the same on that.
No, for sure. Yeah.
And then the question is, how do we try to achieve that goal, right? Of making data-driven organizations happen. You see a couple of developments in this data space. I've depicted them here on the slide. So first, you see a massive boom in tooling and technology, right? Where like a decade ago, you would have an integrated data warehouse platform with all the tools and technologies in one package that made it quite simple. I'm not saying it was fantastic, it had limitations, but it was relatively simple from a tooling and technology perspective. Oh. And you see a massive boom, and this, well, you need to have like crazy super eyes to see it, but these are all little icons of new tools and technologies that have been emerging in the last 5 or 6 years. So there's a massive growth there. Second, you see a massive growth in the number of data professionals, right? This graph depicts the number of data engineers over time. It's a little bit of an older graph, but you could already see this midway last decade, that it was growing rapidly. I recently saw a comment that on LinkedIn in 2021, there were 50% more vacancies for data engineers than the year before, right? So we see a massive growth in the number of data professionals also out there.
I think Python now is one of the top programming languages, from Stack Overflow, right? That's also saying the entire shift, in my opinion, as well.
Yeah, exactly, definitely. Yeah, and then last but not least, I think we are all hungry for data, right? Everybody knows if you want to train a model, the more data you have, the better it will perform, right? So we are all hungry for data. And you see that also in the volume of data, the velocity, right? We have much more devices creating data, sending data to this central data team that has to do something with it. The variety is increasing. These are kind of the developments that we see in this space. And the question is this helping us achieve that goal that we discussed earlier, right? Is this helping organizations become more data-driven? I doubt it, and I have the backing here to prove it.
Data?
Data to prove it, yeah. Good one. So some quotes from first Harvard Business Review. They do a yearly survey with all kinds of data leaders in different organizations. And you see that from 2017 onward, there's a decline year on year in the respondents saying that they are indeed working at a data-driven organization. So it's not getting better, it's getting worse. Well, Forbes the same, right? This was from last year, similar survey. And only 24% of organizations claim to be data-driven. So despite our efforts, more tools, more people, more data, we're not getting to this state of being more data-driven.
And then why is that, right? Is it maybe that now more companies are starting to understand what a data-driven organization means, right? Maybe before a company with a data warehouse was already thinking they were data-driven, but now slowly maybe people are realizing that's not the case, and you need more flexible, more or different types of tools.
Well, it has to do with several reasons. I think the operating model that we have one central team that takes all this responsibility and ingests all this data, makes it ready for consumption, is not an operating model which is scalable. So this model cannot deal with the massive growth in volumes, in tooling, and in people. That's one of the reasons, and that's why I think data mesh is very interesting, because that is kind of a solution for the scalability problem.
Would that also be, because I hear you earlier say, right, we don't trust the data. There's a lot of cleaning going on there in that centralized approach, right? So I can imagine the trust is there, the mistrust in the data is there because, well, it's centralized, and just like my mom doesn't know, right, in that story doesn't know where my stuff goes, the people in the centralized team don't know what the data is actually for, right? So they don't know the context of it.
Yeah.
Yeah, so as I said already, I think this decentralized approach is one of the things that organizations are grasping towards to solve this problem that they have today. And I think this is also a good moment to give it back to you, Kenny.
Yeah. So we talked about why isn't it working, and I think it has to do with the whole shift beforehand, right, from centralization to decentralization in the software industry, which the data comes from somewhere, which is usually the running services that's supporting the business, right? And we had a shift in recent times about building microservices, and it's the same shift where usually people build one monolith and build everything in with a big team, and then the whole agile scene came in, and well, it's hard to build on one system with 50 people, right? So wow, microservices gives us autonomy. That's the promise, right? And well, if you read this book and if you read the data mesh book, they're talking a lot about domain-driven design as well. But it's really ignored, so from what I see at companies, right? Because what happens is usually technologists like myself pick up the book and say, this is really interesting. But then they dive in and it says, well, here in microservices, right? If we want to go to microservices, we need to know which each element functionally to separate the service. Now, what is that functionality in that service, right? That's usually a hard question because there's no connection with the domain. And what then usually happens if we don't have a real good connection with the domain, and I'm going to get to that a bit later what that means, but if we don't have the knowledge to know which functionality is there, then there's no boundaries, and that's what we call in DDD the big ball of mud, which means we're having several functionalities in one system, but they're a bit convoluted, they're a bit entangled with each other. So it's really hard to disentangle that because there's not a lot of meaning to the concepts that are in there. And what's happening then is when they split this one, they split the big ball of mud, and here it gets dangerous because they're splitting data instead of functionality. So then they have the distributed big ball of mud, and that's what happens in a lot of microservices implementations, that they're the technologists, the people who are the ITers, they're splitting the service up.
Yeah.
And they're not doing that in collaboration with their business. That's what we usually see. And
yeah, and that's more like a technology push then, right?
Yeah.
Where I like the microservices concept, so
Yeah.
I'll start implementing it. Maybe even you described a team before of 50 people. Maybe they only have a team of 3 people, and they're still introducing this microservices concept.
Yeah.
So I think those are all things in the microservices, let's say, concept which you need to look out for. But do they translate as well to all of them, let's say, to the data mesh? Or?
yeah, so let me get into that, because what's happening here is, and that's this part, is that once they split it up, now they need to have all these microservices deployed at the same time. So that's what we call the distributed big ball of mud. And what you see now in the agile scene is that they're building these agile release trains to make sure that it's one. But if there's an underlying problem here, is that the software architecture beneath it is already big ball of mud.
Mhm.
So your data is probably also a big ball of mud, right? In the data mesh, they're talking about data products, but if you don't really know what's in the system itself for concepts, then how do you get it out?
Oh.
It's bad from the source. So it makes sense to me that the centralized data approach gets data that's, well, not good, because the people building the microservices and the software don't already know what it is.
Yeah.
Right? So then they're building these agile, which makes sense, right? We need to get into that microservices because we want autonomy, but then they don't have autonomy because now they're coupled in that agile release train. So it's not really an autonomous system anymore. And
is then this agile release train, is that like a smell? Like if you need something, okay.
Yeah, for me it's a smell if you need it, because that means, and there are systems that do need it, right?
Uh-huh.
But it's a smell that your underlying software architecture is not decoupled. And this is something, Eric Evans wrote about in 2003. His book came out in 2003, when microservices wasn't really, you could do them, but they were not really there yet as an architectural approach. But we were building one systems, and he was already seeing the same. And this is the same pattern that's happening throughout the industry, right? The technology improves, but the way we're setting and designing the technology doesn't really improve a lot in what I've seen, because it's still the same concept that they were using in the 80s and the 90s, is how do we decouple our software architecture? And what Eric Evans says is that DDD is about getting a shared understanding of the problems our domain experts have. And that's what we're missing. We're missing the deep connection with our domain expert. And domain expert is a bit fuzzy by default, because they can be anyone. They can be business analysts. They can be really the people using the software, right? So, but it's the people that understand the domain. So I was working in asset management. So a trader would be my domain expert.
Yeah.
I would go to the trader and understand what are your problems.
Yeah, but probably
That's where it starts.
But probably not like a software engineer or somebody with deep understanding in technology, let's say. More on the business side of the spectrum.
Yeah, so what are we solving for? So to give you an example, when I entered that company, in the first week I got a course life cycle of a trade. So I understand what trading means. So I understand what problems do my users face.
Oh.
And that's what DDD is about. If I understand that, I can make better software, because then I know how to split it functionally. I know what their problems are.
Yeah.
So that's the core of DDD. The rest that you find in there, and this is happening in the DDD scene as well, by the way, is the most questions go into how to implement it. What's an aggregate? And that's really tactical. And these are good patterns that you can use, but you don't need to use them. But that's also where you see happening in the DDD scene, same in microservices, and I guess it will happen with data mesh. Eventually it will happen with low code as well, right? We're not thinking about what are our problems our domain experts are facing. We need to understand that.
And maybe adding to that, I would say in the current data space, right, centralized approach, you have the same problem, right?
Yep.
Because these central teams, they are not the SMEs. They are not the domain experts. So they get this data thrown over the fence, ingested in your central data warehouse or in your data lake.
Yeah.
But, how do you interpret it? How do you understand it, right? So it's a similar problem.
And they don't get a similar training as Kenny, right? Like the Trader 101.
And I don't think you should even want to, right? Because are you going to train one central data team or maybe a couple to understand everything from all the businesses where data is coming from? That's not feasible, right?
No, and there's and the harder part is, and we talk about this a lot in DDD, is that there's a telephone game going on there, right? So I might know life cycle of a trade, right? I'm a domain expert. Now you know it a bit. As an engineer, let's say you're a software engineer, you know it a bit, and then you need to explain to him what it is. But
lost in translation.
Lost
right?
in translation. So that doesn't work. So you need to be at the source of the expertise, because I will never become a good trader because they're doing this day in, day out. At least I understand a bit, just enough to implement it. And that's what the main pattern. So there's a lot of patterns and principles and technical, but there's one thing that distinguishes DDD, and that's this bounded context pattern, and that is the key concept in DDD, and that's what, well, in data mesh they talk about as well. We want data products, which we put into a bounded context, which is a model for a specific purpose, right? We create a model there, but a model understandable for our SMEs, right? Our domain experts. Mm-hmm. And the second part, and that's the fuzzy one, is unit of consistent language. And that's why this is not a technical boundary, but it's a social technical boundary because it has language in it. And to give you a clear example, everyone knows a word in our industry or outside the industry that's ambiguous. There was this really fun story about people from America watching the Great British Bake Off, and they couldn't understand what they meant with a cookie. Because a cookie in the UK or in England is something totally different than they would call a cookie in America, right? So there's ambiguity in language, so we try to make smaller models. And I'll get into that a bit later, but the key concept here is that microservices is really an application and deployment boundary. Same with data mesh, right? It's about a technical boundary, while the bounded context is a model boundary, which is not technical, but it sits in between. And this is what we're usually getting. If you look at the left side, you have communication now going into, you have your domain experts, so your SME and team, communicating about a service, or I want that data, or in that system. While DDD talks more about, okay, what is the purpose? What's the model of it? And that's really the shift that a lot of people are not making. They're making, well, product owners are maybe okay still talking about services, but they're making domain expert talk about services. I had someone, domain expert, telling me you need to update that database field. And I'm like, but what do you actually want? Well, if I decide that name, I want the rest of the organization to know. Okay, and now I can solve it in my system. And that communication boundary is usually not there. And that's what DDD tries to solve here. Right? So, and that's the thing I already talked about, that, well, ambiguity in language is a big thing in DDD, right? So a user in one context can be a different user in another context. To give you a clear example, in the Netherlands, each year you need to renew your health insurance. So in November, I already switched to another company. So for that other company, am I a user?
It depends very much on the
definition.
Yeah.
So there's no one definition of user in a company. It depends on the context. So for customer server, yes, I am, because I signed a contract. For contracting, yes, I am. But for payment, not yet. I only pay in January.
And maybe going back to what Peter said initially, right? Mm-hmm. Different KPIs or same KPI having a different value. That's exactly this, right?
Yeah.
That if somebody reports the number of users, maybe finance has a lower number than customer support or whatever.
Yes. And we need to know these, when we design solutions, we need to set a non-ambiguous language for that solution. And I always explain it in the Netherlands as, when I go to the south, I cross a river, and I know they say friet, but in the north we say patat. Right? I know that because and when I go to Germany, I know there's a boundary. Now they speak a different language. We also need to be aware of that in our software system. So when I talk about that model, they call a user, and that means it's a user for that specific business line, and there is user is different. Yeah? So that's the key concepts in DDD. The second part is that model, right? And a model is an abstraction. And really quickly going in there, this is the map we all know, where Greenland is the same size as Africa. In reality, it's not. But why do we know this map? It's because of Mercator in the 1600 created this map. And you can draw a line anywhere on this map, follow that line, and get to your location. Oh. That's the goal. It was to cross the ocean with a compass. And a model always have one particular purpose. But if we build this into a system, and what usually happens then in these big ball of months, is that now I also want the correct size of Greenland. Is that possible in that model? No, it's not. But we do have Greenland in it, so we create another system for that, another model. And that's the thing about data. Data, there's no reality in there, it's context specific. So in this we have a land with, and in the other map we have the correct size. So where do I get the correct reality, so to say, right? So that's the main goal of DDD. That's the main goal of that bounded context pattern. It's a solution created to, well, it's a unit, a model for a specific purpose, right? We're solving one thing in particular. Same if you translate this to a data mesh, we're creating one model to give you one or maybe a few answers, but for a particular responsibility, right? Maybe it's your yearly report, maybe it's something else, but it's for one thing only. And it has a consistent language. And everyone involved, like stakeholders, team developing the software, and the others involved designing the software know about this contextual boundary.
Oh. If you would tell this to data engineers, right? So you can go to a place where you can get a data source, and they have a model and they have a consistent language, and you can understand what's in the data. I think a lot of them would be very, very happy, right? We don't have that today.
No, exactly, because it's at least I now own what's inside, and I know exactly what it is, and it's pure, right? I make sure that my state in the model cannot be in a state that it's not allowed in. That's what we say in DDD, right? We always keep the model clean. So all the data that comes out of that model is clean. And yeah, I think there's, especially for data engineers, nowadays within DDD, you see it going to event streaming a lot, right? With domain events, which also comes from the domain-driven design scene, giving you an event stream of everything that happened in that bounded context. Well, that's just pure need for a data engineer, right? Oh, I can get the entire history of what happens there clean. I don't need to translate it. I don't need to clean it. That's utopia, of course. But as you said, we can get close to, well, we can do better than that 25% now.
Yeah, we should.
So yeah, that's a short intro into domain-driven design.
Yeah, thanks. And then, we'll end up in a situation in the data mesh with a lot of these bounded contexts, but we need some way of actually finding our way within this data mesh. So how to do that better?
Yeah, as I said in the beginning, for me it also comes down to data management, right? And the statement that organizations don't have their data management in order. And I think one of the interesting things of data mesh is the opportunity or the possibility that it provides to also get this data management stuff in order. Right, so on the screen you can see the 4 data mesh principles. I won't go into them. You've done that in the first of the webinars, right? So if you want to know that, check that one out. But I think these 4 principles, 3 of them really add to this data management problem space. So let me explain a little bit what I mean with that, right? So this domain-oriented ownership. And the fact that you would like to have somebody that you can go to and you can ask the question, well, what is your domain model? What is the data that I'm getting? What does it mean? That ownership is currently often not in place, and it's very much needed, I think. And the same is true for data as a product, right? I think many of the data engineers in the audience would agree that data is often not treated as a product when it comes from the source, right? A source system is really about doing a operational business process. That's its primary function. And the team supporting that is really into, how can I make sure that primary business process is going well? And data for others is often a byproduct, right? And this principle talks about how do you make data a product and really make it a first-class citizen. So these 2 things are very much needed to get this data management space in order. If we don't do that properly in the data mesh, it's going to be even more chaos, even more inefficiency. So it's really important to get this done right. I'll go into that a little bit more in detail. And then lastly, this federated computational governance. It's a complicated term from the book of data mesh. But for me, it translates in this is the engineering way of solving the data management problem or the data management issue, right? So data management, data governance is often seen as something which is very bureaucratic. It's a parallel world where all kinds of boards make some decisions, put that on paper, but it's detached from reality where we code and build stuff, right? And I think this concept of federated computational governance is the engineering answer to this problem. And I'll explain later how that works exactly. Let me go through these first 2 quickly. So domain-oriented ownership, what does that mean? These are some quotes from the book. But for me, it's really about this data product ownership, right? So that decentrally in those domains that you have defined with the domain-driven design approach, within the bounded context, there needs to be somebody, a person or a role or a responsibility that owns this data set, and that you can go to and you can ask him, well, explain it to me, and what are the different versions that you have, how is it evolving? You get this idea of a data owner. Well, I've seen this in practice. This is what you get, right? It's not an easy thing. Being a data owner means that you will get all kinds of data users, but also your data privacy officer and who have you will come to you and start asking you questions. So it's a difficult thing to implement. And it's not only a technology thing, right? It's a management thing, it's an organizational thing that you need to do there. But as I said, it's key to get this right. And then second, data as a product, right? So you see here on the screen some of the data product characteristics, and I think if you take those orange symbols, you can one-on-one find them also in the DM book, right? The book of data management. That's very big and fuzzy, but these things that you see here, right? Data needs to be discoverable. You need to be able to trust it. You need to be able to understand it. You need to know how to secure it, right? These are all data management concepts that are in this story of data mesh. Yeah, so that's and last but not least, as I said before, right? If you practice this in the domains decentrally, data is no longer that byproduct of your primary business process, but it's really a important first-class citizen that you use and provide to internal and external users within your organization.
Yeah. And I think some of these let's say product characteristics, they're also caused by maybe the data mesh, right? Being able to that you need something to implement discoverability or interoperability. That's due to the decentralized nature of the data mesh that you need it, right? So does that maybe also mean that it's not for everybody? If you can go with maybe a centralized system, that's still preferred?
Sure. Yeah,
but it's cheaper as well.
Yeah, definitely, because as you explained also in the previous webinar, right? It's not for all organizations. If you are a small organization and you only have a handful of source systems, you don't need to go data mesh. That's overkill, because it's indeed an expensive approach. You need to, if you look into what data mesh requires, you need to have a technology layer, a platform layer. You need to have these different data teams that create the data products. You need to have what they call the experience plane, where you can do the data management activities. So it's a costly affair. It's not for everybody.
Yeah, and you see the same in microservices, right? Microservices is also not for everyone. It's that decentralized approach that it becomes a lot more accidental complex, what we mean, because it's a technology, you're having a lot more communication paths. While if I go to a smaller company, I say just start with a well-designed monolith, which is fine, and it holds its own data as long as you model it correctly inside that boundary, technical boundary.
Yeah.
Later on, if you grow, if you scale, then you can easily transition to that more decentralized approach.
Yeah, so start small, maybe future-proofing it for at a later time when you need to split, but starting small is still...
Yeah, and future-proof is the good one, because a lot of, when I go in, people say, well, you're making it flexible and scalable. I say, no, I'm making it future-proof. I'm making the boundaries already correct in the system, so when you need to move, you can move easily.
Yeah.
Instead of what's happening now, it's already messy at the source. So if it goes decentralized in the data mesh, it's even more messier and complex.
That makes sense.
Yeah, I think you see that often this future-proofing or being ready to split it is not in place, right? Look at your typical data warehouse where you have one central team. It's all intertwined. There are no logical separations within your data warehouse. So if you at a certain point in time want to say, well, I'm now going to split this, I'm not going to do one central team, but I'm going to do 3 domain teams, for example, you won't be able to split your legacy stack. So you need to think about that and get things like this data management already in order also in this central system.
Yeah. I think that's a good question. So how do you do that, right? That's we see organizational charts, and maybe I can go to them. We see organizational charts as something static, right? We set it up, and this is how we do it. But actually, it's a dynamic thing that keeps evolving, right? And how do we get to that data ownership, right? How do I know when to make a correct decision? That's about, well, architecture. That's my sweet spot there.
This is a question that a lot of organizations struggles with, right?
Yeah, I know. And the thing, what usually happens, but before I go into that, the solution, let's first tackle what's a domain. And the thing is, it's already fussy. So people already block on this part, right? Because it's a sphere of knowledge, influence, or activity. It's an area of interest. But in the end, a domain is all about grouping concepts together. And a perfect example, and it's a simple, by the way, and it's obvious example, so don't take this one-on-one as the metaphor in your own situation. But in DDD, we say, okay, can you group a tomato for me? What is it? It's a vegetable? Is it a fruit? So in the supermarket, right? Officially it's a fruit, yeah. But in the supermarket it's a vegetable. Yeah. And a joke, a friend of mine says, Romeo, he comes from France, right, where they have a lot of theaters. In the concept of a theater, it's review, right, because they throw the tomato. Yeah. So depending on where you are, you group it differently. And this is the challenge we face, right, the grouping. So if you go to your supermarket, you think about how do I group it. I think everyone who went to a supermarket might have a chance where they search for a product and they couldn't find it, and then someone guide them to the product and says it's there, and you say why is it there, right? How would you group it yourself? And I've been searching these sections, right? And here you see baby needs and beers and wines grouping at the same thing. Would that make sense to you? Well, maybe in this context it did. Right? Maybe their customers are grouping it like that. Breakfast, a good friend of mine who I don't pronounce her name says, well, I would like to have breakfast, wine, beer, and everything. So that's a perfect concept for me. And the last one, which is the horrible concept, is pain in the back, medicine is on the lower shelf. Well, that's what you don't want to do. But it's all about grouping concept. And this is a simple one because a grocery shop is rather static, right? It doesn't evolve as much as our domains itself, while of course there are some parts of your organization that don't, right? Like finance or risk. These are things that don't change a lot. So that's why that thing. So your first view is how do my organizational chart look? But that's really a static, not a real way of doing it. Then you have software architects who make capability maps. It's already a step lower, which is already a nice input. But if you look at it really, this is the real organizational chart, right? There's a lot of social interaction that we forget about. What's the real communication paths here? So there's a lot of these influences that can impact that grouping of the domains, right? It's customers, first and foremost, I'll say your customers. The resources, right? We're talking about if we do this, it costs a lot because we have a whole different new team of people, but how does it impact for them? Team cognitive load, something from team topology. Cohesion of change, right? What changes together? The change rate, the culture, well, there's a lot of these things. And this is the challenge we're facing. And it's usually in the hands of architects, but they're usually alone trying to analytically model this out by themselves. But when you look at the domain-driven design book, people can also get the feeling, oh, this is that. But a big concept in domain-driven design is a thing called collaborative modeling. Do it together, right? Put people in a room, multidisciplined, right? The people that are actually working with the systems and people that are actually using the system, put them together in the mood and model this out. That means, as architects, we need to skip Archimate because, well, I understand it, but I need to learn constantly. That's not helpful in these sessions. We use a lot of event storming, which is really simple. It starts with an orange sticky called a domain event, and then it's modeled it out in an entire business line. And this is what I a lot of times do in a company, right? I model the entire business line. And then together we decide, okay, how do we group this? Which domains do we have, right? And which solutions or bounded context might end up in these things, right? And this is the grocery shop acquisition, what you're actually doing, right? I'm looking at, okay, how does a person walk through the grocery shop? What do they all need? And how do I group them then in the shelves?
Hey, and then maybe as a counter argument, right? So I think companies do a lot of reorganizations, and do these reorganizations or shuffling of people around, do these impact like these structures you discover during event storming? Yeah,
and this is not static. This is something you need to run maybe every quarter, maybe every year, right? Constantly re-evaluating your organization, your grouping, because the groupings might change. Some might be really fixed, right? Like payment is in this one. Payment might be really fixed. This is, by the way, a fake domain on the cinematic domain, but payment might be really fixed, right? It doesn't change a lot. Same to finance and risk, but your core, where you sell, well, this is your existence of your company. In DDD, we call it the core domain. This is what might change a lot, because you might change strategy. Right? So every time you might want to do that, try to do this. And this is event storming. We also do Wortley mapping, for instance, business model canvas or user story mapping. There's a lot of these collaborative modeling sessions. But this is the thing that we're not doing. Most architects sit there, model it out by themselves, but they're lacking all this information I showed earlier on.
Yeah.
And
So
the information are in the people. So get the people together and then split the software.
So Kenny, what you're saying, if I as an organization want to move towards this data mesh ID, this is one of the things that I need to do, right? So
Yep.
I need to start doing this collaborative modeling with these cross-domain or cross-functional teams within a domain to get clear what's in my data product, what are the boundaries of my data product, etc.
Yeah, and it's and the metaphor here I always give is the open office plan. A lot of organizations I talk to, a lot of engineers say, well, I hate the open office plan, right? Everyone sits with their headphones on. But there's an organization where it worked for. And this organization designed it together. It was 5 teams sitting in one room, and they designed the boundaries together. Which team sits next to the team? And it doesn't mean you involve everyone. There's a lot to it, right? But at least you get a well-informed decision out. So that doesn't mean you need to decide this with 1,000 people, but you get a well-informed decision out, and people could at least say what they had to say, right? And then you make the decision. So it's also a more sustainable one, because people were there and they could give influence to it, if facilitated correctly.
So you create buy-in with that also.
Yeah. If you facilitate it correctly. There's a lot of going into the facilitation there, which is really important, but that's the shift a lot of architects need to make. They need to move from the technical modeling to also be able to lead and facilitate these sessions, making sure to put the responsibility in the teams and in the groups.
That makes sense.
Yeah.
So yeah, that's how you form domains collaboratively. And then you have a shared sense of reality. Then people know, oh yeah, you were from that domain. Oh yeah, I heard from that session. And that session takes a day, maybe 2. And every time you rerun it, it's shorter. So not a lot of investment, if you ask me.
And I think direly needed compared to the way we do it. Yeah.
And then if you switch maybe to the technical, so we've done this exercise in the company, we've discovered a lot of these domains. So how can we then solve it?
Yeah. So as I said earlier, this federated computational governance thing is for me the engineering way of solving this problem. And with this problem, I mean the lack of data management, right? And if you pick up the book, the first sentence in this chapter, I showed it here on the slide, is we need to have a refreshed look at data governance. And that is the missing and final piece to make this data mesh work, right? And I know a lot of people get like, goosebumps or a bad memory when you talk about data governance, like I said before, right? So we preferably don't want to go into discussions with our data governance people. I've been there myself, and I know how that is. And I think the interesting thing here is that we can do it in a different way. We can do it in an engineering way by building all these data governance, all these policies, all these data management things into the system. So we need to embed it into our architecture, into our applications. And if we do that properly, it's not a parallel world anymore. It's part of the reality. It's part of how we actually do IT. And that's very interesting. And what could you get out of it, right? So there are some examples here on the screen that you can automate, right? So there's a lot of fuss also about data catalogs, and we're into this third generation of data catalog products. And it's about being able to find what are all the data products that you have in your entire organization. So you don't want to go to every domain and ask them what's in your domain, what's in your data lake or in your data platform. No, you need to have some kind of central place where you can go to and have insight directly into all the data products that are there. And you shouldn't have a manual way of getting those data products into a catalog. It should be completely automated, coming from all these different nodes in the mesh, right? That's an example. Another one, let's pick the last one, it's lineage, right? So for those who don't know, lineage is that you as an organization can see where data originated, where it moved to, what changed or what happened with the data, and where it's being used. And that's really something you would like to have, not only from a GDPR perspective, but also from an organizational perspective, so you can trust the data, right? Also, that is something that in this idea of federated computational governance, it's automated. So information from these different creators and users of data is automatically sent to a place, and there you can see and visualize that lineage. So that is what federated computational governance means for me. And the big question, of course, is then how? So how do you do that, right? And I'm going to try to keep it very simple. This can become very complex and technical, but I'm going to keep it very simple. What I did here on the slide is I showed you, or I'm showing you the data product plane. So each node in a data mesh has its own data product space, where you have those bounded contexts that were defined using DDD. And from a bounded context, you want to expose data as a product, right? So you have what's called an output port. It could be an API interface. It could be a file transfer. It doesn't really matter. But it's a way of sharing your data product with the outside world, right? And this is something that is decentral. Each node in the mesh has its own.
Yeah, each domain and each part of the domains have several.
Exactly.
So this is a domain, I guess.
This is a domain within domain, maybe several bounded contexts,
exactly.
and each have its own output port, right? What you need to have is also an experience plane. And this is not typically something you do decentrally, right? This is something that you have in one place. You need to have one experience plane where you have things like a data product catalog, data product monitoring, right? Is it up and down? Who is using it? How often is it being used? This is something that you would like to have centrally. You need to design it together with all the nodes so that you have the correct requirements and you have the buy-in, but it's a central thing. And how do you connect these things together? For me, it comes down to metadata. So these output ports, you need to automatically create metadata. Things like, so what is this description of each of the columns, of each of the attributes? What's the classification, right? Are we talking about PII data? Is it particularly sensitive? Can I use it for what purpose? Maybe have some sample data there. At least let people know what is the endpoint that you need to connect to, right? What's the API endpoint, or where can I get this file? All these kind of, this is metadata about the data product. And you need to have that in that experience plane so that people can find it and start consuming it.
Yeah, and I think maybe if I can add, right, I think this is where, you need to find a balance as an organization, right? What do you, let's say, enforce on these data products to specify basically as metadata, or what do you maybe leave out or give people a bit more flexibility to be able to still have different implementations of this data product plane, et cetera, right? I think it's a difficult balance to actually find as a company.
Yeah, so in theory, you could have different technology implementations for a data product plane, right? You could say, well, one domain, I don't know, uses Azure and all kinds of Azure technologies, and another domain has Snowflake implementation, and they both provide a data product via a interface. As long as you do have some kind of some policy, some standardization on what comes out of that interface. What do we expect from that interface? But you could still have different implementations.
It's similar what you saw in the microservices scene, where you also have discoverability and everything, but you wanted to monitor it. So they say, okay, in your REST service, I don't care if you do Python, Java, C# or Node or whatever, but we expect a lookup where you could monitor it, and this should be the data. So everyone could implement that separately, and you get instant, monitorability and observability just by implementing that library, and then it just works. So that's also the experience plane, in my opinion, is what Team Topology talks about platform as a product. They provide this to their domains, or the domains, if they're really specific, right? You have one separate one, then maybe they need to build it themselves, but they need to provide it for their domains, but they're a provider, they're a facilitator, an enabler, and not someone who demands that they need to do it. They actually need to listen to the domains. What's your need, and how do we change it?
Yeah.
Yeah, so this monitoring, with just this, you don't have the monitoring, right? In this picture, you would only have the catalog filled in if you do this. But how do you get to this monitoring and to this lineage that we showed, right? And I think ideally you would want that if a data product is being used by a different part of your organization, internally or externally, that's also something that you capture, right? So and that you create metadata about that. So that's what I showed here, right? So in this example, we have a new domain with its own bounded context. It wants to have some kind of input data from a output port, from a data product, and it uses this as input. Maybe it runs a AI model on top of it, and a new product comes out of that, right? A recommendation or a prediction or whatever. And that's a new output port. That's a new data product. Again, for these things, you would like to have your metadata. So not only the metadata of the new data product, but also who consumed it. And that's the way that you can start creating things like the lineage and really as an organization, get that data management space in order.
Yeah. Yeah, and the nice thing of this concept is that a lot of these things are used for more than one purpose, right? So the metadata is used for the data catalog, but it's also used in the data product monitoring. But it's also used to, let's say, link these different data domains after each other. So it's not that you're only implementing these APIs for let's say, governance purposes. It's the core of the system, basically.
No. So remember that picture that I showed from Kaggle, right? 40% of time is being spent on finding and understanding the data. Well, if you have this product catalog with all this information about a data product, that will save you a lot of time, right? Because you don't need to find that SME in the domain, which is always busy, who is always busy with, doing his business work. You can go to the catalog and find the information that you need.
Yeah, great.
Yeah, and it's interesting what you said earlier, right? That means that teams need to also have less say. This is how you should expose it, right? There's a less autonomous approach to it. A centralized approach, you need to build this in, right? This way. So that can feel constrictive to the teams sometimes.
It does, but it's in the end, I think what the nice thing of a data mesh is, right, that you have this flexibility to choose your own technology. Whereas in a central data platform, it's this way or the highway, right? So I think that's nice. And then if you only specify, you need some governance to achieve interoperability. Basically, that's what we discussed also before. And there's some standards to be made, but like in the microservices way, Java, Python, or Scala, it doesn't really matter, right? As long as you implement the API in the same way.
Yeah, as long as you communicate in a sort of similar way. And that's why, to go quickly into the last one, that's why it makes it a decentralized sociotechnical approach. This is a nice slide from a friend of mine, Trond, right? Really depicting it correctly. Is on the right side you have the technical part, and on the left side you have the structure, but the last one is the people. And the cognitive and the social part. This is often forgotten. And the thing what you're saying is there's this hype about high-performant autonomous teams, and I think autonomous is the incorrect word, because you still need to have a sense of what's happening, who am I collaborating with, where do I find what. Understanding of each other in that sense is people, right? Because you cannot be autonomous in an organization.
No.
It can't. Because and that's the balance what you said before, right? You're a part of the system, but you're also part of the whole. And this is what we call a polarity between the two. So centralized and decentralized is part and whole. And here's what you see, right? You need to balance them. And each one has positives and each one has negative, right? So the part is you can turn into isolation, but the good thing is uniqueness. I'm using Python or Java to solve my business problem because it's unique and my problem is a bit uniquer. But then at the same time, you need to stay connected, which is the positive of the whole. But if you're not careful, you're in the sameness, right? If you do everything as a whole, then we're all doing the same thing, and then nobody could do their uniqueness anymore. So as a manager or as architects, right, we need to keep balance of this. And that's why it's a social technical approach. And that's why collaborative modeling is such an important thing in this, right? Because there you can spot the signals when you go to the negative effect of each one of these, right? And I've already gave a talk about this, so don't go into this further. But this is the whole social part about autonomy. Is that what we really want? I say no, it's a balance in between. And I did this talk with another colleague, Evelyn, who's more on the social science part here.
Hey, we got a question from Joost, maybe to Peter. Do you have any recommendations for, let's say, ready-made commercial products to store this metadata? Do you have any experience with that?
Yeah, that again, as an architect, I would say that depends, right? That depends very much on the context that you are in, what kind of systems you already have. What you see now is, I showed that picture of the data tools and technology boom, and you see that a lot of organizations are now trying to build products that are able to fulfill that question, right? So in the Azure space, you see Azure Purview, you have things like Calibra, Atlan, Atlassian. These are all players in that space. And you see some kind of startups, small tech organizations that think they can do it better. They often have the right idea, but they don't have the mass and the capacity yet. So it's an evolving space. I don't have one particular tool that I would advise.
And the good thing is, I think there's already a lot of people, again, in the organization that knows this, what there is. So again, that collaborative modeling, putting these people together and discuss which one should we go for, and even do experimentation on it.
Yeah.
Right? Try several products first, cheap, and see how it works, and then pick one. Again, in what you say, in a year, that startup might have grown, but if we would know the future, I would be rich, right? So
Yeah.
Yeah, and maybe one thing I would advise here is try to decouple it a little bit. So if you are in control of that metadata yourself, you can put any product on top of it because you still have the metadata. And if you indeed try out a certain tool and you think, well, this is not working for me, it doesn't have the features that I need, as long as you have the data yourself, you can always put a new product on top of it. So that would be an advice there.
Yeah, I think it's good advice. So have this independent metadata layer from your products, go to the independent metadata layer, and then maybe into the commercial catalog.
Yeah, and you could put your data engineers on top of that topic, right? The people that have been doing data analytics and have been gathering normal data, you could say. It's a similar problem, right? It's just a different type of data that you're trying to collect from different sources. So
a lot of people are dealing with legacy, so it's a similar.
Yeah.
You need to involve that as well. So this is the final part, right? To wrap up, as in data mesh is an investment into technology and especially the people. This is a quote from Nicole Forsgren from Accelerate. She's doing the State of DevOps yearly. Would totally read that book if I was you. And really, collaborative modeling is really such a good method or practice to use to do this. Yeah. And the last two.
Yeah, so as I said before, right, for me the interesting thing is here it's an engineering approach to solving a problem that used to be a very bureaucratic thing. And maybe last is so getting your data management in order is not only limited to data mesh, right? Also if you have this centralized approach and that works for you, you should still invest in getting this data management thing in order.
Yeah, great. Yeah, so looking at the time and also I think at no questions from the room, so maybe it's a good time to slowly wrap up. Peter, Kenny, would like to thank you for your time and also the contributions to this discussion. I thought it was a really nice discussion we had, the three of us, and I would like to thank everybody at home or at work for joining, and maybe until next time. So see you then.
Thanks.
All right.
Okay.
Thanks.
Bye-bye.
Bye.